coming to the next part, as I have told you that the understanding of a scalar product in vector is very important, and we can extend this concept to the wave function in the quantum mechanics as well. So let's say you have a vector, let's say a vector. How we can define a scalar product of two vectors? So let's say if I want to define a scalar product of two vectors, so this can be denoted as this bracket notation, like if I write a vector A and this can be defined as the B, something like that. So this is called as a scalar product, right? Now, if I take a scalar product of two vectors, A vector with itself, something like that, so it will give you the value of magnitude square of A. And if I am talking about the unit vectors along I, j and k, something like that, so we can take a scalar product of I with respect to I, z with respect to z, and k with respect to k, and that will be equals to 1. And if I take the scalar product of I with respect to z with respect to k, and k with respect to I, that will be equals to 0. So this is called as the orthonormal basis system. This is called as the why we call it as orthonormal basis system? Because if you see the magnitude is equals to 1 and all of these vectors are perpendicular to each other, as we can see here in the Cartesian coordinate system, and that is why it is called as the orthonormal basis system. Right? It's very important. Now coming to the next concept that I am talking about in the vector, because if let's say if you have a vector, as I have discussed, a vector that is equals to axi Ey plus azk, and if I want to find out the coefficient ax, how we can find the coefficient ax? So if I take the dot product of I cap with respect to this vector a, then that will give you the component along x direction. If I take a dot product or a scalar product of z with respect to vector a, that will give you ay. And if I take a dot product of k cap with respect to vector a, that gives you the coefficient az. And why we are studying these things? Because I'll be extending this concept to the quantum mechanical wave function, and there we will be using this concept to calculate the coefficient of the wave function along